Okay, we're going to start getting ready for our unit circle by doing some pre-work here. So this is we're going to do a few things from these notes before we do our unit circle activity. So this comes from the sections 4.2 and 4.3. Pulled out a little bit of both there. We've already looked at the trig functions, sine, cosine, tangent, and their reciprocal identities. Now we're going to take a look at a couple other things. Let's take a look at this picture here. It says, will angle theta have the same trig values regardless of the triangle used? So let's say that this is a 1:2 ratio there. And let's say that we magnify the sides and we make this 2. So from here to here, let's call that 4. Or if we make it bigger and we say this large triangle here has a side of 6 and this has a side of 3. So we have 3 different triangles. We have 1:2, 2:4, 3:6. Will the angle have the same trig values? And the answer is yes. Theta does not change. So the sine, cosine, and theta, the ratio between the sides, are all the same. Because the triangles are similar. Similar triangles. The ratio between the sides remain the same. Okay, so that's a little review of geometry. Okay, let's review reference angles. We talked a little bit about reference angles already at the beginning of this chapter. It says a reference angle is the acute angle, which is always positive, formed by the terminal side and the x-axis. So this right here is the reference angle, terminal side and x-axis, terminal side and x-axis. So you should know what reference angles are. We've already done those at the beginning. So let's take a look at a circle. The equation of a circle, and again, some of you may or may not have learned an equation of a circle. X squared plus y squared equals r squared is the standard equation of a circle centered at 0, 0. R is the radius. Okay, so any point on the circle is x comma y. Okay, so if we drew a circle, any point on the circle would be x comma y. So let's just say this is a point on the circle. This is the radius, r. So this is your x distance, and this is your y distance. So instead of using SOHCAHTOA, another way that the trig functions are taught is by memorizing the ratio with the x, the y's, and the r's. I don't tend to use x, y's, and r's. I just like my SOHCAHTOA. Opposite over hypotenuse. That's y over r. Okay, that's where the y over r comes from. Cosine, adjacent over hypotenuse. X over r. Opposite over adjacent, y over x. So any point on a circle, again, we're going to start talking about the unit circle. Any point on the circle is always x comma y. Okay, and what we will learn here is that the x is always equal to r times the cosine of theta. So x is going to be the cosine of theta times your radius. Y is going to be the sine of theta times your radius. And on the unit circle, our radius is going to be 1. Okay, so this is just another way of associating trig values. Instead of using opposite, again, we use the y value because this is the y value over x of y, radius of a circle. Okay, so the cosecant would be r over y, or we could just call it hypotenuse over opposite. Secant is r over x, and cotangent is x over the y. So it's another way of thinking of SOHCAHTOA. Again, I tend to not refer to that very much, but some teachers do. I like my SOHCAHTOA. I think it's easier. But again, that will come into play a little bit on our unit circle. All right, so let's take a look at example number 1 here. It says, find the 6 trig function values of the angle with a point 3, 4 on the terminal side of angle theta. Okay, so we're going to draw a picture with that given information. We're going to go over 3 up 4. So that's over 3 up 4. Okay, so our x value is 3. Our y value is 4. What's the radius? Well, that's one of your 3, 4, 5 triangles that you should have memorized. Otherwise, a squared plus b squared equals c squared. It'll take you a little bit longer. Okay, so if I use my SOHCAHTOA on these, I can do my opposite over my hypotenuse. Or I could use my x value over my r value. Oops, I'm sorry. My y value over my r value. Sine is y over r. See, I told you I don't have those memorized. Sine is y over r. So that's my y over my r. Cosine is x over r. Tangent is y over x. Okay, and then these are just the reciprocals. Okay, so again, it's just another way of saying SOHCAHTOA. We're relating it to a point on a circle. We're using x's and y's and r's instead of opposite, adjacent, and hypotenuse. Just 2 different ways to think about it. Okay? Take a look at this next page here, example number 2. Why don't you go ahead and try that problem and pause the video. I would try it on your own. Pause the video if you have not done so. Okay, so here's the answer to this one. -5, positive 12. So that's -5, positive 12. So that's -5, 12. So our x value is -5. Our y value is 12. The hypotenuse, 5, 12, 13. That's another Pythagorean triple you should have memorized. 5, 12, 13. Or a squared plus b squared equals c squared, which will take you a little bit longer. Okay, so sine is y over r, 12 over 13. Cosine is x over r. And tangent is y over x. And the negative can go on the top, on the side, on the bottom, one or the other. So we have 13 over 12, -13 over 5, -5 over 12. All right? All right, now let's look at determining the sign, positive or negative, of the functions. Now this is very, very important. Okay, the signs of the trig function, the 4 quadrants, can be determined easily by the definitions of the functions. So if you look at the cosine, x divided by r okay, would always be positive when the radius is always positive, right here. R is always positive. That's the radius. So in order for our cosine to be positive, our x would have to be positive. So looking back up here, our x is positive when we're in the first and when we're in the fourth quadrant. So cosine is positive in the first and in the fourth. Okay, when will sine be positive? We'll think of it this way. The sine of theta is equal to the y value divided by the r value. So when the y value is positive, the sine will be positive. So again, if you're looking back up here, when is your y value positive? In which quadrants do you have a positive y value? Well, you have a positive y value in the first and in the second quadrant. So this is positive when y is positive, which is in quadrant 1 and quadrant 2. So we already said cosine is positive here and here because our x is positive. We said that sine is positive here and here because the y value is positive. But what about tangent? Tangent will be positive when x and y are both positive or x and y are both negative. So when does that happen? So again, I'll just draw a little sketch right here. So x is positive, y is positive in the first quadrant. So first quadrant, and again, it's 1, 2, 3, 4, counterclockwise. Is there any other place where x and y are both positive? No. How about when x and y are both negative? Well, x is negative going in this direction, y is negative going in this direction, so quadrant 3 is where tangent is positive. Okay? So you're going to have to know where all your trig functions are positive and negative, in which quadrants. So let's take a look. Again, this is very important. In the first quadrant, tell me about tangent. In the first quadrant, tangent is positive. Sine is positive. Cosine is positive. All trig functions are positive in the first quadrant. But how about when we go to the second quadrant? Our x value is negative and our y value is positive. So if our y value is positive, y divided by r is our sine. So sine is going to be positive. If you look at the ratio, so look up here. This is the second quadrant reference angle. Look at what's positive here. Sine and its reciprocal. Everything else is negative. So tangent is negative and cosine is negative in the second quadrant. We go back to the example number 1. What's positive when your reference angle falls in the first quadrant? All trig functions are positive in the first quadrant. Okay. Example number 2. Only sine and its reciprocal are positive. Everything else is negative. Okay, well, what if we were in the third and in the fourth quadrant? Well, if we look up here, we have already proven, or we've already talked that the tangent is negative in quadrant 3. We've already said that. We already wrote that down. So tangent is negative. What about sine and cosine? Well, we said sine is positive in 1 and 2. Well, if sine is positive in 1 and 2, then that means it must be negative in the third and negative in the fourth. And again, if you checked SOHCAHTOA, you would figure that out. So if we go ahead and we look at this, just a generic picture, a reference triangle, we have our x value is negative, our y value is negative, and our radius is always positive. So this is a negative, this is a negative. So when you do SOHCAHTOA, you have a negative divided by a positive. That's going to be the sine. You have adjacent divided by the hypotenuse. That's going to be negative. That's the cosine. Okay? When you do tangent in the third quadrant, that's opposite over adjacent. That's a negative divided by a negative. I made a mistake. That's supposed to be positive. They both, x and y are both negative in quadrant 3, therefore tangent will be positive. I made a mistake on that one. All right. And then the last, let's take a look at, let's say you have a, and again, I'm just going to draw a generic reference triangle in the fourth quadrant. Here's your reference angle. Okay. X is positive. Y is negative. The radius is always positive. So when you do SOHCAHTOA, opposite over adjacent, opposite over hypotenuse, or if you want to say y over r, it's the same thing. That's negative divided by a positive. So that means the sine is negative, and we already have that. Okay. For cosine, adjacent divided by hypotenuse. Adjacent is positive, hypotenuse is positive, or x is positive, r is positive. Positive divided by a positive is positive. Then we do tangent. Opposite over adjacent. Negative divided by a positive. Y divided by x. Negative divided by a positive is a negative. Okay. So I just went through and showed you why all of those are positive and why they're negative. Now you get to memorize them. You could always, if you forget, you could always draw a little picture to help you remember. Now here's a little saying here, all stupid teachers cheat. Yeah, I like this one better. All students text constantly. What does that mean? All students text constantly. All students text constantly. What does that mean? All of the trig functions are positive in the first quadrant. Sine is positive in the second quadrant. Tangent is positive in the third quadrant. And the C, cosine, is positive in the fourth. So all students text constantly is a way to help you memorize which trig functions are positive in which quadrants and which trig functions then would be negative in which quadrants. And it's very, very important that you know when they're positive, where they're positive, and where they're negative, which quadrants. Now, having said that, sine, when you flip over sine, you get cosecant. If sine is positive, so is its reciprocal. If tangent is positive, so is its reciprocal. If cosine is positive, so is its reciprocal. Everything else will be negative. Okay? So very, very, very important for what we're going to be doing in the near future. Example number 3. Based on what I just told you, go ahead and see if you can figure out the answers to example 3, A, B, C, and D. So go ahead and pause your video and go ahead and try them on your own. Okay, I hope you paused your video. All students are positive in the first. All students text constantly. Cosine is also positive in the fourth. So state the quadrant or quadrants in which theta will terminate. Well, that means the terminal side is in one of these quadrants. So it's quadrant 1, or it's quadrant 4. That's where theta, the terminal side of theta, will end. Okay? For sine being negative, it's positive here, sine is negative here, and negative here. Okay? And I like to just put check marks, because then wherever the check marks are. So let's do this one first. I'll do that in red. Sine is negative here and here. Where's cosine negative? Well, they're all positive here. Cosine's negative here and negative here. So where do both of these happen? In quadrant 3. Okay. Secant. Where is secant negative? Well, secant is negative, the same place cosine is negative. So cosine is negative in the second and in the third, because it's positive AC. Again, going back up here. All trig functions are positive in the first. Cosine is positive in the fourth. So it must be negative in the other two. Positive in 2, negative in 2. So that goes with the secant. How about the tangent? Where is the tangent negative? Well, again, tangent, all students text constantly. This 1 and 3 is where tangent is positive. So that means it's negative in the second and negative in the fourth. So where do these both happen? In the second quadrant. All right. And then the last one. This goes with sine. Where is the sine positive? First and second. Cotangent is positive. Oh, yeah, I'm sorry, this is negative. Tangent is negative when cotangent is negative. So we need to find out where tangent is negative. Well, I know it's positive in the first and positive in the third. So tangent and cotangent must be negative in the second and in the fourth. So where do they both happen? Quadrant 2. So again, that is a question that is testing your all students text constantly. And it's very, very, very important for much of the trig that we are going to do in the near future. Okay, one more example here, example number 4. They're going to give us some information, kind of putting together everything that we just did. It says that the tangent is negative 5/4 and the cosine is positive. Well, we know it doesn't tell us which quadrant to put this in. All it says is the tangent is negative 5/4. That could be negative 5/4, or it could be 5/-4. So how do we know which one it is? Well, where is the tangent negative Well, the tangent is negative here and here, second and fourth. But where is the cosine positive at the same time? That would be right here. So the reference triangle that we have to draw, you have to figure out the quadrant because it's not just automatically given to you like it was here when it gave you the coordinate. So by putting this together with our All Students Text Constantly, we can draw the reference triangle in the fourth quadrant. So now that we know that it's in the fourth quadrant, we know that our opposite side, that's 5/4. So opposite over adjacent, which direction is negative? Is that a -5 or is that a -4? Well, this is going down. So this is going to be negative. Okay? So now we need to find, so we know that our x value is positive, we know our y value is negative. What is the radius? Is that one of our special triangles, 3, 4, 5? Well, some people think it is, but the 3 cannot be the hypotenuse, so we have to use the Pythagorean theorem. A squared plus b squared equals c squared. So that's 25 plus 16, which is 41. So c equals the square root of 41, and that's your radius. So again, you can stand on your reference angle and you can do SOHCAHTOA, or you can do x, y's, and r's. Totally up to you. Okay, so for sine, it's going to be a -5 over the square root of 41, which you need to rationalize. For cosine, that is adjacent, or y, over r, which is 4 square roots of 21 over 21. Tangent, opposite over adjacent, or y over x. And then the reciprocals. So do not flip over the rationalized answer. These two are one and the same. They're the same number. Type it in your calculator. You'll get the same number. This is just rationalized. So I'm going to take the unrationalized. You should be able to know that this came from this, even if I didn't tell you. You should be able to unrationalize in your head. Okay, you should be able to see, if I gave you 4 square roots of 21 over 21, you should know that that came from 4 divided by the square root of 21. That's going to be something that will be useful in the near future. So if I flip this over, it's best to flip over the unrationalized one, so I don't have to worry about rationalizing. Square root of 21 over 4 and -4/5. Okay, so that's the end of the first part of the lesson.